Good day and welcome to Lesson 7 in this series. Under Lesson 7, we'll be looking at maintenance safety or the concept of safety in maintenance. My name is Engineer Sonny Oboji and I'll be taking us through this lesson. To start with, what is safety? Safety in maintenance is concerned with freedom from danger, protection from, or not being exposed to risk or harm or injury during the process of carrying out maintenance procedures. Maintenance by nature involves a lot of risky operations where the technician or the engineer gets exposed to risky environments filled with different kinds of hazards and whatever. And the chances are that if he or she is not careful, he might get injured. Other human beings around can also get injured from, we have issues like cuts, like slips, like falls, like electrocution, and so on and so forth. So safety is concerned with freedom from danger and all sorts of risk associated with injury or harm in the course of maintenance. Now, we must talk about the issue of exposure to hazards. Maintenance is carried out in every workplace and in all industries. Workers involved in maintenance activities may be at the risk of developing musculoskeletal disorders, MSDs. Musculoskeletal disorders when they perform tasks involving bending, awkward posture, occasionally in different movements in difficult environmental conditions. For instance, when it's too cold or when it is too hot, you see there's a lot of movement of the muscles, or repeated movement of these muscles. Workers tend to develop musculoskeletal disorders. That's one hazard that they are exposed to. Then other hazards will include respiratory problems which are related to exposure to harmful chemical substances such as asbestos. For instance, as you try to carry out maintenance, facility maintenance on old buildings and whatever, there's the risk of exposure to asbestos fumes. And asbestos has been found by several research to be carcinogenic in nature, and it could cause serious respiratory problem in addition to every other problem that it can cause for the body. There's the issue of skin and respiratory diseases due to contact with dangerous substances, ranging from greases to solvents to corrosive chemicals and dust, including carcinogenic wood dust. All these can cause skin and respiratory issues. Then we have asphyxiation in confined spaces. Now, what this means is in confined spaces, especially where there's a reduction in the amount of oxygen that is in circulation, and also where you have gases that are unstable, like carbon monoxide and whatever, which will want to scamper and absorb the oxygen in circulation to reduce themselves to a more stable form. Like carbon monoxide will tend to want to move to a more stable form called carbon dioxide. What happens is that it competes with the human beings to try to absorb the oxygen that is in the atmosphere. And every oxygen that is used to reduce it to carbon dioxide is no longer available for the human beings in that space to use. As a result of which you see asphyxiation setting in, and which could lead to fainting, could lead to, people falling into coma in extreme conditions. There's also the issue of diseases resulting from exposure to biological hazards. Diseases such as hepatitis A, Legionella, and so on and so forth. They also face accident risk of many types, including falls and being hit by a piece of machinery. All these are different kinds of hazards that maintenance crew or maintenance personnel could be exposed to. The list is not exhaustive. There are so many other hazards that maintenance crew could be exposed to. For instance, those that work around grinding machine could get caught. Those that work with electricity, you could have issues related to shock and electrocution and so on and so forth. In particular, I want to examine dangers of electricity, the dangers of electricity. And the major danger when it comes to electricity is the issue of electric shocks or electrocution. Now, electric shock, it depends on the amount of current that the individual is exposed to and the length of contact or how long the contact takes place. For instance, an electric current of 1 milliampere within the interval of a second contact, the physiological effect it generates is like there's threshold of feeling some tingling sensation in the body of whoever is making such contact. Now, when you have current levels that are 5 milliampere, then that's the acceptable limit for harmless current. So from 1 milliampere, you begin to feel some tingling sensations, and you could go as far as 5 milliampere. Anything beyond 5 milliampere, definitely there's going to be some harm, some shock, some damage caused in the life of the individual. When current levels go to about 10 to 20 milliampere for a 1 second contact, then you have issues like sustained muscular contraction. That's the point at which it seems as if the current is holding onto you and not allowing you to go. Then when the current level increases to about 100 to 300 milliamperes for a 1 second contact, then we have issues like ventricular fibrillation, which could be fatal if continued. If that contact is not broken, it could be fatal. It could lead to death or respiratory impairment, though the respiratory function might still continue. But if it goes beyond the second, then we have more critical issues resulting from that. Current levels of 6 amperes could lead to sustained ventricular contraction followed by normal heart rhythm, defibrillation, temporary respiratory paralysis, and possibly burn. So we see from the distance that as the current level increases and as the time of contact also increases, the dangers associated with electricity increases. The adverse effect will be directly related to the level of current, the length of time that the body is exposed, like I said earlier, and the path that the current takes through the body. The effect is physiological, the same as damage caused by an open flame. If you get exposed to an open flame, you suffer some burns and everything. The same thing applies to electric current or other high temperature source of heat, except that in the case of electricity, it has the ability to burn the tissue well beneath the skin of the victim, even burning internal organs. Normally, when you're exposed to gas from fuel or whatever, it burns the surface. It depends on the intensity of the flame and the length of exposure. That's where it can burn internal organs or whatever. But in most cases, it is the skin that is affected. But in case of electricity, the effect goes deep, even into internal organs within the body. If electrical current of sufficient magnitude is conducted through a living creature, it tends to override the tiny electrical impulses normally generated by the neurons, overloading the nervous system and preventing internal signals from being able to actuate muscle. That is when issues like stiffness begins to come or lack of response because the neural system has been overwhelmed. Even relatively low currents can often scramble nerve cell signals enough that the heart cannot beat properly, sending the heart into a condition known as fibrillation. When fibrillation sets in, the heart flutters rather than beating, and it becomes ineffective at pumping blood to vital organs of the body. And once these organs are starved, death process begins. And finally, death from asphyxiation or cardiac arrest will generally result from a strong enough current flowing through the body. That is why, for safety reasons, we encourage insulation, the highest form and the most appropriate form of insulation, so that you are not exposed or no part of the body is now used as a conductor for the flow of electric current to move towards the earth. The next thing we want to look at under safety in maintenance is machine safety checklist. Every manufacturer, every standard manufacturer, if I must say that, will normally accompany a machine with what we call a machine safety checklist. It's a checklist that draws the attention of the operator or the maintenance personnel or the engineer to what checks that need to be carried out to ensure that everything is intact and in the appropriate condition before that machine can be operated. Having a safety checklist on hand helps the workers to verify that a work site is safe. There are many topics related to machine safety that should be considered in any safety plan. And this includes mechanical hazards. For instance, on a machine safety checklist, you see questions like, are the guards in place? Is there any form of leakage? Is there any vibration that is visible or noticeable? All these things draw your attention to the kind of checks or inspections you need to carry out before running or operating the machine. On the electrical hazard axis, you see issues like, are there any exposed conductors? Is there any form of short-circuiting? It helps you to answer questions. It will prompt you with questions that in an attempt to investigate to answer these questions, you will determine whether electrically it is safe or not to operate the machines or not. Then all the other hazards that are associated with the machine, which might not be strictly tied down to mechanical or electrical hazards, protective equipment, maintenance and repair, the safeguards in place, and then training. For instance, have you been adequately trained? Do you know how to operate it? Do you know how to start and stop normally? What if you have to stop the machine as a matter of emergency? Do you know where the switches, where the buttons are located? You know the procedure to bring a machine to a stop in emergency situation. All these questions and probes are in a machine safety checklist, and it will help you to know the right procedure for operating a machine and the right procedure for going about, maybe when you have to stop a machine or you want to carry out some function as it relates to the machine and the environment of the machine. Then we want to look at accident prevention regulation, APR, in maintenance. Accident prevention regulation. Now, normally we say accidents are unplanned occurrences that result in injuries, illness, death, loss of property, and production loss. Accidents can be avoided or reduced by a number of factors. Before we look at the factors, we consider the factors or the ways that you can reduce accident. I must stress that every accident is cost. Every accident is cost. It could be by the negligence of the operator, the negligence of the engineer, or the negligence of whoever designed or installed the piece of equipment. But every accident can be traced to a cause, either negligence, sabotage, or whatever. And if every accident is caused, then there are certain things we need to know to be able to prevent accident. But as a simple key, there are questions we can ask ourselves in the issue of preventing accident. The first question is, what are the risks, the biggest risks today? And we must understand that risks change with time. The risks that are there today might not be there tomorrow. The risks that were there yesterday may have escalated today, and so have to be accorded priority attention at a greater level, at a higher level than they were accorded yesterday. So question one, what are the risks associated, the biggest risks associated with this environment, with this machine today? The next question that follows this is, what can be done about the risk I've been able to identify? Then the third question, what controls do we have in place? If there are risks that I could entirely eliminate, fine, I eliminate them. If there are risks that substitution can help me to mitigate, then I substitute the parts, the components, or the work procedures in place. But if elimination and substitution cannot do the magic for me, then the next thing is that I need to look at the controls I need to put in place to make sure that I am shielded from those risks. And then what if, the fourth question is, what if the controls fail? What if the controls fail? So the steps that we can use or strategies we can use to avoid or to prevent accidents include, firstly, know the hazard. Know the hazard. Be aware of the surroundings. Are there spills on the floor? Do we have cluttered walkways? Are there things that are suspended that could hamper my standing straight if I need to stand very quickly? Be very, very conscious of the surrounding or the environment around where you're working as a maintenance personnel and the machine, or around where the machine is located. Look around, identify workplace hazards that could cause harm. Identify ways to reduce or eliminate the hazards and implement ways. It is one thing to identify them, it's another thing to eliminate them or implement the strategies that you know can reduce or eliminate them. So we must identify and also implement. Then we must report unsafe areas or unsafe practices. There's nothing like being sentimental here. If you know that there are unsafe practices engaged in by colleagues or other human beings around, it could cause big issues for you. The carelessness of another person can result in accident and it can affect you. So there's nothing like sentiments here. If there's any unsafe areas or unsafe practices that has been identified, it should be reported so that corrective action can be taken. Then we dress for the weather. When it's too cold or extremely cold, you dress with things that can help you build or retain heat. When it is too hot, you dress lightly so that you will not find yourself having to sweat and getting, losing water excessively from the body, and so on and so forth. We use job hazard analysis tools to identify hazards associated with job types. Different job types are associated with different kinds of hazards. And it is our responsibility to look at the job, look at the steps, the tasks involved in that particular kind of job, and then identify the hazards using job hazard analysis tool. So in summary, step 1 is know the hazard. Step 2, create a safe work area. Create a safe work area. How do you achieve this? I could give you some tips. Keep an orderly workspace. Poor housekeeping can cause serious health issues and safety hazards. The layout of the workplace should have adequate exit routes and be free of debris or things that are falling that tend to clutter the workway, because you might not know when you might need to use the exit on an emergency basis. We've had situations where in some industries you see that pallets and stack of products or whatever are used to block exits. And then there's an emergency and everybody begins to try to escape through a single exit. And then you see some people being trampled upon, and so on and so forth. So exits must be left free of debris and whatever so that it can be used when the need arises. As part of creating a safe workplace, we should inspect vehicles before and after use, and of course, drive them safely. We should continually cultivate a safety standard. There must be standards. There are international standards, there are industry standards by regulatory authorities, there are in-house safety standards. Whether they are in-house or by external agencies or international standards, they must be enforced and they must be complied with. Then we must learn to take breaks and move around regularly throughout the day. Small breaks, standing up, moving around can make a big difference in combating the dangers of staying in a static position all day long. Now, let me explain a little. There's what we call the temporary threshold limit. What it means is that as a human being by nature, you are designed in such a way that if you are exposed to any form of disturbance, it could be loud noise, it could be some vibration, it could be heat, any form of disturbance that you are exposed to, you could endure it, your body could take it, and it may not cause any permanent damage or destruction for a while. So After exposure, continuous exposure for about 20 minutes or about 20, 30 minutes, you need to take a break and break the flow. If you are working in a very hot environment, you need to just take a stroll for 1 or 2 minutes from that place so that the buildup of heat can be broken and your body can auto-reset. And when you come back again, it's like you are free, you are clean enough to be able to withstand that environment for another length of time. So we must learn to take small breaks to break the flow or to break the buildup of things that could harm us in the long run. Then pay attention to workstation ergonomics. The principle of ergonomics dictates that the workstation must be designed in such a way as to suit the needs of the particular worker. And there's no one size fits all here. So we must pay attention to workspace ergonomics. The way we sit, the way we stand, our freedom to be able to move parts of our body in the course of our work, all these things are addressed in workspace ergonomics, and we must be able to pay attention to them. The next way of preventing accidents is to use safe lifting techniques. Follow the safe lifting practices, the following safe lifting practices, and I will explain it. For instance, you lift from a position of power. You lift from a position of power and you keep the load close. Even for machines like forklift, it is encouraged that the center of gravity of the load should be closest, as close as possible to the center of gravity of the body or the one doing the lifting. In case of forklifts, if you attempt to lift a load with your forks that is far away from the center of gravity of the forklift, you might have the forklift overturning. The same thing applies to the human being. You want to lift a load, you move as close to the load as possible, and you make sure that you are balanced with your legs wide open a bit and not just jammed together as if you are standing at attention. You spread the legs a bit, about 1 foot apart, and in a V formation. Having done that, what do? You lift the load from a position of power, and you ensure that even while lifting, as much as possible, the center of gravity of the load is closest to your own center of gravity. Thereby, you can lift the load. And it is encouraged that during lifting, manual lifting, as much as possible, we bend at the knees and you bend at the waist. Any attempt to bend your back can lead to some fracture. It can lead to some musculoskeletal issues for you. So you squat at the knees and bend with your back upright and your neck upright, and you can be able to pick whatever you are lifting. And once you have a load suspended between ground level and wherever you are taking it to, don't twist while lifting. Very, very important. Do not twist while lifting because it could cause some damage to your vertebral system, as the case may be. Training in body mechanics can reduce strain injuries, and keep employees safe during lifting and moving of objects. The next preventive strategy is the use of PPEs, personal protective equipment. There are different kinds of personal protective equipment. For instance, you have crash helmet, which prevents you from whatever is falling. You have safety boots, which prevents your feet from falling objects. And some of them are even reinforced with metal shields at the toe so that it will prevent the tip of your feet from getting crushed under the weight of falling objects. We have overalls that you can use to cover your body, shielding it from death, from chemicals, and from other things that could affect or injure your body. We have hand gloves, appropriate hand gloves. They are mechanical hand gloves that prevent you from cuts and physical injury. There are electrical hand gloves that are insulated to prevent the flow of current through your body. There are nose masks, ear. We have goggles for the eye, and we have different kinds of protection for different parts of the body. The emphasis here is that we must make sure that we strictly adhere to the culture of using personal protective equipment as a means of protecting or shielding ourselves from injury, especially where you cannot entirely eliminate the risk. You must learn to live with them, and the only way to do that is by use of PPEs. Then regular communication is another preventive strategy. Notify supervisors or whoever is in charge about safety hazards. Don't cover them. Don't pretend they do not exist. It does not make you a lazy worker when you notify them about those things. It should actually be celebrated and you should be commended for doing that. Then we must speak up and be involved in safety planning because you are the one that is working there. Your life is there. It is your life that is exposed to this risk. So we must be involved in planning for safety and then continually cultivate safety standard. We must continually cultivate safety standard. The last strategy is education and training. We must ensure that everyone has a proper safety training relating to the hazards of the job. We must take advantage of environmental health and safety training programs because at these programs, we are made to identify hazards. We are exposed to drills like fire drills, how to be able to react or respond when you have emergencies like fire and whatever. We are trained in all those. And then first aid, the dynamics of first aid, how to be able to administer first aid, what to do when somebody is in danger near you. And that split second response could be the difference, could make the difference between life and death for the person that is in danger. It is each employee's responsibility to take an active role in maintaining safety. So we've looked at safety as it relates to maintenance. We defined safety. We looked at the issue of exposure to hazards, the kind of hazards that maintenance crew members are exposed to in the course of maintenance activities. Then we looked at the dangers of electricity in particular. And there we identified the fact that as the time of contact, the interval of contact increases, and also the amount of current flowing through increases, the harm becomes significant, leading to even death. Then we looked at machine safety checklist and some accident prevention strategies. The most important thing about safety is that everyone involved in maintenance must take responsibility for his or her safety. We must take responsibility by learning all we need to learn to be able to identify hazards, to be able to take countermeasures to prevent ourselves from, being trapped in accident situations, and to be able to help others so that they also will not suffer injuries or will not be harmed or will not even die in the process. Thank you very, very much.